Okay, did we have any questions on 2 through 8 evens? 2 through 8 evens. Any questions on 2 through 8 evens? Yes. Okay. Now, what I talked to you guys about was graphing. Okay, did you graph it on the graphing calculator? Okay. Secondly, where you think there possibly is an open bracket or closed bracket, you need to evaluate that x value. So you need to basically plug it in. So that's why I use the trace button, and then I type in the number that I'm trying to figure out. Is it included or is it not included? Now, are you talking about like vertical asymptotes, or are you talking like where the graph just like makes a dead stop and you're trying to figure out if you should include it or not? Yeah. The dead stop, that's where I'm going to, like if I look at it and go, okay, it looks like it's stopping at -1. Then I'm going to hit the trace button, I'm going to type -1. If it says y equals 17, I know that there's a y value, there's a point there, I should include it. If it says y equals, and there's nothing there, then I know that that point doesn't exist. Okay? The other alternative is to do the algebra. Okay? And you do need to understand the algebra. Are there ones in here, 2, 4, 6, or 8, where you, like, hopefully on number 4, you were paying attention to the x plus 5. What do you know about x plus 5 from question 4? It has to be greater than or equal to what? 0. Because it's one of those radicands, right? It's underneath the radical, so x has to be greater than or equal to -5. So that probably was showing you things like this, you know, for a domain, going from -5 to infinity. Yes. 6 or 8, sure. You know what I should have done? I should have used something else so that I didn't have to do this. Okay. I'll use this. No, I don't want the camera. Seriously, why is it doing that? Let's try this again. Come on. No cam. Start with video? No, I don't want to start with video. That's better. Yeah, much better. Okay, you said 6 or 8, and 6 we're looking for f of g of x. Alright, so here we've got square root x minus 2 over square root x plus 4. Okay, strictly from an algebraic perspective, x minus 2 has to be greater than or equal to what? 0. And then here we've got x plus 4 has to be greater than or equal to 0, but that happens to be in the denominator of a fraction. Which means what? Did we just lose? It can't equal 0. We just lost the equal to part. Gone. Because it's in the denominator of the fraction. Okay? So, if you solve this, that'd be greater than or equal to 2. If you solve this, this would be greater than -4. That's interesting. Now, both of those head in the same direction, do they not? Okay? So, back in middle school, we might have seen something like, you know, -4, +2, open circle, arrow right, closed circle, arrow right. If you wanted one or the other, what would you end up with? One or the other. Now, we are using the mathematical term or, not the English term or, because in the English world, you only get to pick one. In the mathematical world, you get to pick one or the other or both. I know, that's weird. But what would you end up with? Name all the points that fit into one of those groups. Name all the points that fit into one of those groups. -2, yeah, that does. I mean, if we're going to do this one at a time, man, we're going to be here a while. And I'm probably going to end up dying here, right in this chair. Okay, so -2 is in that list. Do we got another? We got any? Can we describe like all of them at the same time? Maybe. If you name all the points that fit into those sets. Wouldn't you be like that right there with the blue? What? Okay, now, I know what she's thinking. 2 to the right, she's thinking and. She's using the and, the intersection of the two. I don't need where they just are in common. I need all. That's why we used that term. Okay, so let's go graph this doggone thing since I keep saying graph, 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 graph. Yeah, I know. Square root is on fire. That's what that song says, isn't it? Ooh, am I wrong? I feel like I'm wrong. Which I'm shocked about, but hey, when you're wrong, you're wrong. You have to admit it. Okay? It's not like an English class where we just say, well, we think this is what the author meant. 16 different interpretations, but not yours. I hate that stuff. What did the poet mean? Yeah. At least in math, I know if I'm right or wrong. From my picture, it's looking like I'm wrong. From my picture, it's looking something like this. So maybe you're right. I thought it was the or, but maybe it is the and. Because if it was the and, then you would have to be right.
Was I right?
It's appearing from the graph that you are. Now, I'm going to have to study that to figure out why.
Oh my god.
But it's appearing that we were talking about the and, which would be what they have in common. Wow. Because the graph looks like this, and it's at 2, and 2 would be contained, and I bet if I hit trace and type a 2, we got a coordinate. We do, 2, 0. So it does work. I think it does work that way. Interesting. Nope, it's exactly 2, 0. So 2 is included. So the domain for that would be 2, infinity. Okay, now if we switch it around, what happens? Whoa. Alright, so if we switch this thing around and we went square root x plus 4 on the top and square root x minus 2 on the bottom, the picture ended up being really bizarre, like it starts up in thin air and then just... Now, it could be... Yeah, I'm thinking. That's what I wish everybody did, but can't all get our wishes. Oh, interesting. Wow, that is so cool. I know, maybe not to you, but it is to me. Okay, we find our vertical asymptotes where? When you're looking at these functions, how can you easily locate your vertical asymptotes? You have to look where? Well, I know the equation, but where in the equation? I'll give you a hint. Okay, like charades. Denominator, thank you very much. All right? Okay, it's the denominator of the fraction, okay? But where did you find a denominator issue down there? Okay? -4, you see -4 down there in the bottom? That's the problem. Okay? Where is -4 in this graph? Way over here to the left, not even a part of what's going on. Okay? But over here on the one on the right, when you're looking at the top is suggesting that x is greater than or equal to -4. Okay? But what is the bottom suggesting? Well, there's something else it's suggesting. What's the problem with the bottom? The problem is 2. So the top is suggesting greater than or equal to -4, but we've got this going on right here. We've got a vertical asymptote. And you remember you asked me, how do I know if 2's involved or not? Because when I typed in a 2, it didn't give me anything. That's how I knew it wasn't included. So this, for the reverse G over F, is having a domain of x is greater than 2. Why am I saying it like that instead of writing it the normal way? Gee whiz. Who let this guy in the room? Okay, so from 2 to infinity. Wow, that's cool. Yes, folks, this is the deep water. I understand. Yeah, this is. I'm really pushing you to think here. I understand that. Yes. The G over F. Yes. G over F, which was this. G over F. On the G over F one? So, right. So there's no value there. That's why we have the red one. Not the blue one that's closed. The F over G the F over G was the closed one. The first one we did, F over G, I know this is a mess. Okay? The second one, which was that one that kind of looked like it was stopping, but it is following the vertical asymptote right here. That one is not included too. Correct. Because that's what goes along with what she was asking me. Thank you very much. Too many things to think about. Yeah, like right above 16. Yeah, exactly. Okay. I can answer more questions later. I want to get back to notes. I know. You know what? I'll leave. I'll cancel that. Alrighty. It's already online. What did I just do? Okay, how do I undo here? Because I had Okay, composition of functions. The notation on the left is not my favorite. Okay, if you were at a party or at billboards or commercials and you saw that notation right there, it would be read F following G of X. The reason I don't really like that is when most people look at it, they're pretty much in a fog. Come on, that's good stuff, folks. Seriously. It's like 2-hour delay kind of thing. Which we obviously didn't get this morning. Okay. I know, it was really foggy on my side of town, not yours. But, I know. It definitely discriminates. I am much more a fan, but the notation on the left is seen and is used by AP Calculus, so we are going to see it and use it. However, I like the other notation on the left, F of G of X. Okay, if you want to read that, somewhere where you find that commonly used, F of G of X. The reason I like the notation on the right is because it deals with parentheses. And from a young age, whenever you were dealing with multiple sets of parentheses that were embedded in each other, what was the rule? Where did you start? When you had multiple parentheses inside of other parentheses, where did you start? The innermost parentheses, and you worked your way out. That's the same logic that you're using here. This is called a composition of two functions. We use these things all the time. Have you ever made a spreadsheet? Well, you need to learn how to use a spreadsheet if you haven't. Because when you take values from one cell and use them in another, and then use those in another, and then you go back and change the original one and all the other cells change, you've done a composition. You've used one cell to create a value and then used that value to create something else. Typically things like sums, totals, and all kinds of other things. All right. Whenever I see this notation right here, I do this. Just because I don't like to look at it, but that's just me personally. Same thing with the other one. But that's just me. This function that's on the outside, the function that's on the outside controls what's going on. Is there a question? Or just random conversation? What means? Okay. Like a dissertation, or is there a question though? Oh, like F following G? It just means F comes after G. Oh, you were just helping. Nice. I like it. It's always good when people are helpful. Because someday you're going to need the help. And it's just nice when people return those favors. Okay. The part that's on the outside. What does the F function tell me to do to every value I put into it? What does the F function tell me to do to every... Ooh, I should change the color on that just for fun. I know. piracy. Oh. What does the f function, the one on the outside, tell me to do to every value that's put into it? Well, if I was telling you, if I said what is f of 5, what would you be doing with the 5? You'd be plugging it in for x, right? And you would take e to that power, right? Okay. So we are being instructed to take e to some power. Now I have used a set of parentheses to hold a place because something is going in there. What's going in there? G of x. What is the g of x that's going in there? The square root of x. Okay, now here's my next question. Are those parentheses useful or useless? You have about 20 seconds to talk to your neighbors and figure out whether you think those parentheses are useful or useless.
For aesthetic purposes. Just to make sure you have it.
Don't lose it.
Yeah. It's kind of like when you put like a bag inside a bag.
Oh yeah, so nothing leaks out. Hey, that's a good idea.
I'm a cashier. I know that.
Yeah, there you go. There you go. Is it useful or useless? Useless. The reason I say they're useless is because nothing is being done. There's no more operations that can be done. If someone asked me to simplify that, there's nothing I can do. Nothing. So those parentheses are useless. Now, I'm not saying that we're not going to come across some situations here that are where they're not going to be useful. I'm just asking that question for now. Right? This is the same thing as saying e to the square root of x. You know, it looks like a y. I don't know. Come on. Oh my goodness, I'm doing a poor job. All right, now let's. What's the domain of that? I suggest you graph it. Come on, graph it. The E to the X button is on the left side. It's right above the LN button. No, folks, that's not an IN button. Right next to the number 4. The picture I got was kind of weird. It does like this and then this. I don't know. I'm kind of exaggerating that little movement right there. Yeah.
How come the radical x goes up to how come the square root is radical?
That's what G of x is. That's it. You look at the G of x. That's what they gave.
No, I mean, why is it taking the place of the x?
Because when we're composing, we're taking two functions, and we're taking the x out of this one, and we're replacing it with the other function. So the reason I put those red parentheses up there was because I was taking the x out, and I was replacing it with the other function. All right. Now, sometimes those parentheses are going to be useful, and in this case, they are not really that useful. Okay, now, What do you know about the radicand? I'll circle it in red, the radicand right here. What do we know about it? It can't be 0. Well, it can be 0, yeah. Can't be negative. Now interpret that. Can't be negative means greater than or equal to 0. There you go. That's one of those things we talked about as one of those basic rules we really needed to know. Does that make sense with the picture? Yep. 0 to infinity. All right, now what happens when we reverse that? G of f of x. Oops, use a different color. Come on. The one on the outside, G. What is it telling you to do to everything you plug into it? Take the square root of whatever you plug into it. So just like that. You see that I put the square root. I took the x out. I put those parentheses in there. What's going inside there? What do we add? The f of x, which is e to the x. Are those parentheses useful or useless? Nice try. Useless. They don't do anything because you can't simplify. There's nothing. Well, I guess we could write it a different way. So, yeah, we could be all nasty technical and, write something like e to the x to the 1/2, which is e to the x over 2. We could do that if you want to take us back to our Algebra 2 days. What's the domain? And why did it suddenly open up to negative infinity to infinity? Square root of e to the x. Because what? So that picture that you got probably looks something like this. It is negative infinity to infinity. I do agree with you. What's the lowest value you can think, or what do you know about e to the x? Tell me what you know about e to the x. Tell me what you know about e to the x. Do you know the approximate value of e? At least tell me that. 2.718, right? It's right outside my door, right on the door. If you read it, you'll understand, right? Okay? 2.718, is that larger than 1? Which means it would be exponential growth, right? Right? What's the lowest value you can possibly come up with on that graph? What do you know about that? Exponential growth, right? Think about that in your mind. You know that if you go way far to the left, you get the lower values, right? Over here, it gets bigger and bigger and bigger and bigger and bigger. Over there, it's getting smaller and smaller and smaller. And what is it getting close to? 0, right? Will it ever reach it? No. So it'll never get to 0. What do you know about square roots? Square roots, what kind of numbers can they handle? 0 or larger, right? But never negative numbers. But that's okay, we don't even get to 0. You can plug any number in there you want for x. You're never going to get 0 out of it, let alone a negative number. So the square root won't have any problem with it. I know we're asking you to analyze a lot of things here, folks. All right, so now we're doing letter A here, G of f of x. I'm getting lazy. I don't want to switch colors. The one on the outside controls what's going on. What does it tell you to do to everything you plug into it? What does it tell you to do to everything you plug into it? Take the square root. That's what the G function says. And so what are we going to put in those parentheses? X squared minus 1. Are those parentheses useful or useless? Pretty much useless. You're like, one of these days you're going to be right. Okay? I know, I'm setting you up. Okay? There's going to be a big spike at the end. Okay? So just be ready. Alright? So, we've got useless parentheses. So really we're talking about this right here. Now, I am going to make a big deal out of something here. This right here is what we would call the unsimplified form. Now, don't make fun of me, okay? There's a point to what we're doing here, okay? There is a method to the madness, yes. You're probably going to say, well, the unsimplified doesn't look a whole lot different than the simplified. I do realize in this case, folks, that doesn't look like a whole lot of difference, because there's not really a difference, okay? But the point I'm trying to make is that we check the domain over here. Never over there. Don't you ever check the simplified form for the domain, because I promise you, I will find you an example where you will end up getting the wrong answer if you find it from the simplified form. In fact, you want to graph this one. So, when you're thinking about finding the domain and graphing, do it from the unsimplified form. I know it's not going to make a difference in this particular example, but it will in the future. In fact, what do you know about x squared minus 1? What do you know about x squared minus 1? Well, that's true. We could factor it. I don't think that's going to help, but it might. So x squared minus 1, since it sits under a radical, means that it has to be greater than or equal to 0. We've said that several times with those radicands. Man, I'm running out of room here. So that means that x squared has to be greater than or equal to what? 1. Right? Because you add that to the other side. And how do you get x by itself? Square root, right? What that's going to create is a situation that looks like this. Go graph it right now on the calculator. Go graph it. See what it looks like. Graph it so you can understand why I'm saying it's split. The one you just copied down. So you got a picture like this. It's coming in, the meteor's coming in, then dies, right? And then suddenly it reappears and goes out the other side. Almost looks like a side view of a basketball. You know the lines on it. Never mind. You can tell on the graph that you have everything from -1 below and everything above, so your domain would be what? negative infinity to negative 1, union what? 1 to infinity. Now, we need to get this reversed and do the next one, or do this one. I'm not going to get to example 4, okay, because I think we need to focus some attention on it. F of g of x. And man, I'm running out of room here. This is not cool. So what is the f function telling me I need to do to every value I put into it? What is the f function telling me to do to everything I put into it? Square it and subtract 1. Square it and subtract 1. What are we going to put into it? What are we going to put into it? The square root of x. Are these parentheses useful or useless?
Useful.
Thank you very much! Because the square and the square root cancel out. Would we call this right here the unsimplified or the simplified form?
Unsimplified.
This is the unsimplified form. And what do we need to do with the unsimplified form? Graph it and check for the domain. Because I promise you, if you simplify it, you're going to get this. X minus 1. Now, all of you know that x minus 1 is a line with a slope of 1 that goes through the y-intercept of negative 1, and every one of you would conclude that it's all real numbers if you graphed y equals x minus 1. But what do you get when you graph this thing right here? What'd you get? Square root x. Oops. Can't type. You got a line, or more likely, I should say, array. You got an array that went up like that. What's the domain? Come on, what's the domain? Smash it all on the x-axis. How much of the x-axis gets covered? 0 to infinity. Does it include 0? It sure does. But I promise you, if you'd simplified it all the way and then graphed it, you would have made the wrong conclusion. You would have said all real numbers when that's not true. The unsimplified form is where you have to stop to check those things. I lied because we have extra time, so we will decompose these functions. They're not bodies, folks. They're functions. Okay, so it won't be gross and disgusting. Now, decomposition means we're going the opposite direction. We're starting with a composed function, and we're going to go backwards, and we're going to create. Yes, folks, you're going to make up two functions that would be composed in exactly the same fashion they have suggested to get this particular conclusion. Now, do you notice in letter A that there's an x plus 1 and an x plus 1? Do you see that? Okay. I'm going to let you create f of x, and I will give you g of x. G of x, as you just stated, is x plus 1. The part that you're plugging in to the f function is x plus 1. Now you tell me what you think f of x is. Okay? Write it down. Write down what you think it is. Look at the pattern of what they have there. Yes. No. No. The first part was right. Think about replacing those two things. your attention on that top line. So do the square root, because the square root belongs with the bottom. Okay, because we're taking this, and we're plugging it into something, and we're ending up with that. What are we plugging it into? You guys getting any start on this? Okay, so imagine that we replaced these two things with an X. What would it look like? If that was your conclusion, excellent. Okay? Because think about it. They're taking that x plus 1 and they're substituting it because the f function's on the outside. It's the one controlling everything. So you would have parentheses squared plus or minus 3 parentheses plus 4. That's what the f function is saying. And the g function would be what you're plugging into it. So, what about this last one? Yeah, don't quit on me. Don't be quitters. Stop being quitters. Okay? How about the last one, right? For letter B here. I'll let you figure out f of x. G of x is x cubed plus 1. It is just the square root of x. So I knew you were right on that second one. I knew you were right on that second one. Okay? So that goes with letter B. Excellent work. Have a wonderful weekend. Enjoy it. Don't get hit in the parking lot.